Welcome back to another Dev Diary entry. I need to come up with a better name. Something like that, though. Bit of another disrupted week. So I'll be honest, this isn't... I wouldn't say this is my best work, but I think we're making progress. And I think, yeah, for a hobby side project, that's all we can aim for. Two sort of changes in particular I think worth chatting about. One is I've refactored slightly. So if you've watched so far, you'll know on the game state I had a separate player and entity manager. I've merged them so the player is an entity in a known slot. I think that's made things slightly neater. I'll post the link to the tagged commit in the description. It's dev13. So if you do want to go poke around and see the changes, you can. But quite formulaic. But I think the thing to point out, this iterator pattern, I think it's a neat Odin pattern. I'll go through that quickly first, because I didn't know it, and so it's probably useful to know. And then we can talk a little bit about pathfinding. So I've got very basic enemy pathfinding in. I don't think it's good enough forever, but I think it will be good enough to get us started. So we can, I don't know, reflect on that when we get back to it. On the entity manager stuff, you'll see in here, I've just hard-coded that the player should always be in slot 0, and then anything that wants to refer to the player can do so through that ID. So our entity manager has a buffer. It's a static buffer. For example here, yeah, there you go. So get player says get the player index out of that buffer. I've kept... Oops, what's the matter with this? I've kept a handle to that here. So the game state still has a game.player, which is just a pointer to that slot in that buffer because it's stable. Which I think is just convenient. But yeah, quite a small change. Part of why I've done it, though, is we have quite a lot of logic. Obviously, we have a lot of logic that cares about this being the player in particular. We also have logic that's just kind of like, hey, is there a thing here? Right? Like if I'm drawing the grid tiles, I need to know, do I need to go and look at whether I'm a floor? Do I need to draw the floor button and have the floor actions on it, or do I have an entity that needs to be handled differently? And that handled differently is really like quite a small distinction between player and enemy. So really having them as a single thing kind of made sense. You can imagine that will expand out, right? Like if we get to a place where we have explosions that deal damage in an area, that will need to just know all the entities. It doesn't care players and enemies so much. So I was like, it'd be nice to tidy up our iterating. So I sat and had a bit of a look at it and found that there is a neat pattern for this that I didn't know about. So I've defined an iterator, which is just kind of a transparent reference through to the entity manager with an index on it. So it's got a bit of state to know how far through it's gotten. What I said here. I've got an init function, which determines whether or not we're including the player. So you can start iterating at 0 or at 1, depending on whether you want to include the player in your iteration. So you get either all the enemies or you get all the entities. And this is the neat pattern I didn't know about before, is if you return a trailing Boolean, you can use this in a sort of neat for loop. So you see here, I can do for entity in this thing, and entity is equal to the field that comes before that Boolean. I'm pretty sure you can add more as well, so you could have like entity and index, and then the return type would have to just be entity and int and Boolean. But if you'd seen the old version of this, I think what I was doing was I would call the function once at the start and set a bunch of local variables, and then I'd call the function again at the end of the loop to update those local variables, and I was then using those variables as my sort of tick condition inside of the loop, which essentially does the same thing. but it does it in a less, I don't know, ergonomic way. So that's a neat pattern worth knowing if you're writing any Odin. Should we look at our pathfinding? So I've done this through a thing that I've seen online called Dijkstra maps. I'll try to remember to put a link in the description. I think I'm blanking on his name now, but the guy who wrote Brogue, I think wrote an article explaining these. I've not read in its entirety, but in the first paragraph, he tells you how to do it, and so that's what I've done. So the idea with these is we've got lots of enemies that all want to pathfind towards the player. What we can do is we can just say, okay, across the floor, work out distances to the player, and then enemies can just step to get close to the player. So I don't know if this is particularly interesting to actually step through. It's not the neatest code in the world. Maybe it's easier to draw a little diagram rather than like step through the code explicitly. If you imagine we've got like a bunch of boxes for our grid. Bear with me. It's silly to draw these when it's already on square paper. Never mind. So if we've got, this is our playing area, and then let's say that this is impassable, and this is the player. So the sweep you do is you first set all of these to some very large number. I think I'm doing something like int 32 max over 2. So there's a bit of room for arithmetic without overflowing, so that's a bug that I hit. But so we do that. So these have all got a huge number in, and then the thing that you want stuff to pathfind towards, you set to 0, right? So it's got 0 distance from itself. You then, now, this is maybe the naive implementation. I think you could maybe be able to like flood fill from here. But what you've got to do then is just iterate over all of these. And if I look at this one, I check its neighbors, and if any of them have a lower value than I currently have, update my value to 1 more than that. So in this case, you go sweep, sweep, you sweep to here. You go, my value is huge. His value is 1. This becomes a 1, right? This is impassable, so stays huge. That gets a 1. That gets a 1. That gets a 1. You then sweep again. This time we get 2, 2, 2, 2, 2, and 2. And then the last pass would come through here and get 3s. And then you do a final pass that finds nothing changes. The grid is filled, and you'd use this for your pathfinding. Let's say I want to find a path from here to the player. Well, a valid step would be to this spot, or this spot. They'd all do the same thing for me, right? They'd all allow me to get to the player in 3 steps. And that's fundamentally what it's doing, right? So if you think that there could also be other stuff in here that's blocking, so let's imagine I had 2 enemies, then actually what we do is we just check these as candidates. We go, that's not actually valid though, because there's an enemy in it. And I'll actually step to here. We then do the same thing, and it chooses one of these. It would step, and it gets itself up next to the player. I think it's quite nice because it's calculated once per player move, and then you get all of your enemy movement easily. I think the Brogue article as well, what he's saying is there's a huge amount of behaviors in roguelikes that really boil down to, I want this thing to move to get closer to some goal / one of many goals, and this is a very good way to quite cheaply calculate all of that. Cheaply as in like without having to write too much logic, and also without having to spend a lot of computation. So the obvious downside to this, you need to keep that Dijkstra map updated. So you can imagine if we just made a mess of this now, haven't I? But if we take this here all out, obviously if the player steps from here to here, I guess if you know a clever trick, I don't. I'd be very happy to hear it. But I couldn't think of a way to then cleverly update this that was simpler than to just redo those iterations, right? I don't think there's some like local rule to very trivially say like what the change to these should be. Although thinking about it now, maybe there is, right? Because the delta on his position is -1 and 1. So if you're above it, you likely go down. Although this one's above it and goes up. I think that's the thing. I think if there were no obstacles, I think you could do it quite simply. But the obstacles, I think, make it hard to reason about. The other thing that I wasn't sure about is this iteration scheme. I kind of wonder if you'd be better off doing like a breadth first search, right? So you go check, 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 check. And because it's breadth first, we'd visit all the things closest to us first. And then when you continue outwards, it continues doing this like check your neighbors and set your value to 1 higher than your nearest neighbor. Sorry, to 1 higher than your smallest neighbor. And then you would do it in a single pass through the grid. It's probably something I'll come back to. I think I've left it to do in the code saying I think it's worth experimenting with, yeah. Currently, it's not so slow that it matters, so I think I'm just going to use this until it does become too slow to matter. I also think it's one of those things where, I don't know, computers are hard, and so this kind of iterating over everything strategy is obviously a lot more steps of work, but I'm guessing it's also better for cache usage, right? Because I'm accessing things in sort of little blocks. So as I'm iterating through, I think things like the predictions for the next accesses will be more effective. I think that can get you like up to 100 times faster, right? If you're comparing like L1 hits to L3 hits. In which case, the fact that I have to do 20 iterations to fill this out, so kind of 20 times as many computations, but if they are on average 80 times faster, that ends up being a wash. That may be nonsense. I suspect in this case it probably is nonsense, right? Because this isn't particularly optimized either, and the breadth first search probably does win. But I'll say, I don't know, performance is hard to reason about, at least in the abstract. So I'm going to worry about that if it becomes too slow. Look at this. This code's so dumb as well. I've just very manually been like, there are 8 cases, and so I've written 8 cases. Don't judge me. Was there anything else kind of interesting? I think the only other thing that was interesting is having written that, so that's quite a formulaic piece, right? I've got enemies, they're going to be able to route toward the player. And of course, the first thing you then find is life isn't actually that simple. Can I find a slightly bigger room? Because enemies need to be able to kind of route around each other as well. So if I am stood, let's say I'm here, we spawn a pair of rats in, and I wait. I want to have them step toward me. It's then unclear whether this rat should step to a side to let this rat through. So that's an AI choice you can make. But let's say here, so we step to here. This rat's now got space to get around this other rat. And it should do so, right? Like, if I let it step, it should come up to here. What about if I've just got lots of rats? Let me just keep spawning a whole bunch in. So I've got 1, 2, 3, 4, 5, 6, 7, 8 rats. So in an ideal world, I would like these to neatly envelop the player if they get the chance. If we wait, you'll see that they do it over time. Right, so here, this is probably the interesting case. This rat wants to move up to here and hit me. These rats also want to let it, right, is the kind of thinking I've got. So either what I want is for rats to start sliding around so that this rat can get in, or this rat should start pathing around everybody to get to here. And that's a choice, right? Those are both valid. Hopefully, if I just keep doing this, you'll see that the current implementation, what I've got is, if I try to move and I can't move, but there's an enemy in at least one candidate position I could have moved to, we ask it to move, which I thought was useful to implement because it just guarantees that the way we've got it written makes it easy to access kind of enemy state again. which I've not done in a particularly clever way. If you think our entity manager gives us access to all of the things that are going to act, right? We've got a buffer full of entities, and entities have all the information about like the stuff that you need to know for how they interact, such as, for example, ask to move. But actor Q kind of separately contains the information about when it's going to move. And again, I was looking at this, I was like, I wonder if we should really put this next active information on those entities, and actor Q should just be indexes into something. But I don't know, I've not sat and thought about that any harder. Yeah. In fact, looking at it now, I think that's an easy change to make, and I think it's probably worth doing. Let me make a to-do to consider that. Moving next active to... Because the sort of thing you end up finding that's then annoying is obviously our heap for getting the next entity off is useful because it's a min priority heap, so I can request the minimum value and it's extremely cheap, right? It's a single lookup to get, and that's a maintainable property that's cheap to maintain. I think scales like log of the number of entities in it. Much cheaper than, for example, sorting a buffer every time that we insert something. But it means finding a thing is not cheap. So I think currently when I want to know, hey, when does this particular enemy act, what I have to do is scan. In fact, that's probably in here if I go looking for it. Is it execute get next active? Yeah, it's me thinking about the same thing, right? Currently we just scan the entire thing, so it scales like n, which again, these numbers are small currently, so I think it's not massively worth worrying about. But it felt like a point of unneatness that's spread, so maybe that is worth thinking about. Sorry, I've derailed myself. What was I saying? Yeah, so entities have this ask to move bit of state on them, and in their movement logic, in fact, we could probably find where it's referenced, and you will see, so there it gets set at the point that somebody else is moving, and if, probably this one's the reference, we say in here, if I'm active and I can see the player, I cache ask to move, and clear it, and then ask to move is down here. So it says, if I could bite the player, but I've been asked to move, I choose to not bite the player, and we continue our what's it called? We continue on our algorithm to find the movement candidate. So in this case, what we had, this rat asked this rat to move, this rat asked some other rat to move, and then they can kind of have this cascading, like, now it's free, you move, then I move, then he moves, and everybody gets in. So it kind of guarantees this sort of behavior. Where it is less than ideal, if we have more than 9 rats, we allow them to kind of get in here, we will find that there's a couple of rats in here, potentially these 3, who are just being asked to move constantly and they can't move. And so things that should be doing attacks aren't doing attacks. This is where I've decided to leave it for now. I think this kind of like mobs of enemies coming in and enveloping the player is probably a useful thing for us to have as we build out the kind of melee combat system, which I think is probably the next thing to do. But you know, this behavior is not ideal, but particularly when we're starting out with kind of programming the simplest and weakest enemies. Likely what you have to think is the player will kill this one, the player will kill this one. Like the odds that we're going to get through all of these rats for several rounds and that sort of not biting behavior becomes really significant, it's actually probably reasonably small. There's the other issue, right? Is that you saw that kind of cascading move because of the series of asks. That was really dumb behavior, right? Because like there was a gap here this rat could have gotten into. This rat could have stepped aside and left a gap, and this corner rat didn't need to move. But our logic's not that clever. But I think I'm drawing a line under it here because this is one of those problems where once you start thinking about it, it actually turns out it has lots of corner cases that are worth thinking about. I think this is going to become a significant chunk of the code we write once we've got the kind of core systems in, is making this sensible. I also think what sensible looks like depends probably on what game mechanics we have. So I think probably we're going to leave this where it is. We'll implement other core systems that I want to like a bare minimum standard. Maybe even sit and write down a little like design plan of like, okay, these are the enemies that I'm planning on having. This is the ways that I want them to interact. And at that point, I think come back and do this more robustly, because I don't know, surprisingly tricky, right? To do completely, to do in a way that's really nice. And I think it's important that this piece does work nicely, right? The game, it's not going to be interesting through having lots of nice graphics, right? Like, the game is entirely going to be worth playing or not worth playing based on how AI works. I want it to be predictable. I want it to be intuitive. Right, I want you to just kind of be able to look at the enemies and be able to kind of intuit what the sensible things they are likely to do will be. And that little segment there that I've just played out where they all kind of shuffled around without biting you, that's not intuitive. That's really stupid. So, I don't know. But I think it's good enough for us for now. I think the Dijkstra map thing's really interesting. We'll have to see how far we can push that. I'd be surprised if we get away without ever implementing just like an A-star search algorithm for like, I am here and I want to get there. But, you know, those sorts of things are fun to implement, right? That's kind of half the point. So we'll see how we go. But I think good enough for now. We can sort of get moved on. Like I say, if I remember my own notes correctly, I think the plan is now... Well, I think the plan has been for a while to kind of add a combat system so you can start doing damage and taking damage. Yeah, that's a point. I've not done that yet. I would quite like to be able... I don't know what change I've made in there. So you can see as I'm playing that I can click around here, and because of the player getting centered, this works reasonably well. It's not perfect, right? Really what I want to be able to do is click there and move there. And I couldn't do that before, because really what a click there needs to mean is the player moves here, and then we process enemy moves, and then the player moves here, and we process enemy moves, and then here, and process, and here, and process, which we didn't have in place before, which we have now. So that's on the list as well, to be able to just click here and kind of trigger a bunch of moves. Probably do that fairly cheaply, because currently all we do... What would it be? I think it's in main. We have this process actors field on game. And you can see here, we continue processing actors until we hit the player, right? So the game will continue to pump for more actions, and this is how we then like process lots of rats all acting. For example, again, I didn't do it straight away because another thought occurred to me that maybe it's worth putting in the README. That I think it's slightly unpleasant. I think a common way that roguelikes work is exactly like what I've just said. But I don't think it's particularly pleasant if I am learning the game, that if I spawn a bunch of rats in and I walk away, that all of their actions all kind of happen at once, right? And I think the way that this then gets controlled, and this is on our to-do list, would be you then put a little message window down here. So what I see is all 5 rats move. Right, if I come around over here, I see a load of rats all move. And then the little window down here tells me, he bit you, he moved here, he did this. I don't think it's the best UX. I think it'd be nice to have it so that as you're moving, I move, and then I can see like each individual move with maybe an indicator for where they've come from, or maybe it flashes like a little indicator on them so where they're going to, or the direction they're acting in, and then they move. But you do also want that to be really quick, right? Because the whole point of it being sprites or text-based and not having animations, I think the reason that people actually like that, right? This isn't just a trade-off people will accept. I think people who play these games like this. I like this. Is it makes them very fast. And if we start adding too much fluff, like if I click here and it then takes 5 seconds because each rat gets a second before I get to move again, I think we slow the game down too much and it becomes annoying. So it may even be a toggleable state where I'm like, now I'm in combat, I now want to see enemies' moves more precisely. I think this whole thing about what points we stop processing, I think, could get more complicated. And so I think I want to do that at the same time I think about this multi-move thing, just because they're related, right? They're both about changing this processing logic. I think I've waffled quite enough. Like I say, it's been a... Oh yeah, I do want that. To do. It's been a slightly busy and interrupted week. I don't know if you live in the UK and you're watching this in the near future, you'll know we've had a bit of a heat wave the last week, and so half the time I've spent grumbling that I'm too warm, the other half I've spent out in the sunshine with my family. So I've not had as much nerd in the basement time as I perhaps would have liked in a normal week. Who knows? I was going to say hopefully things return to normal, but let's hope the sun keeps shining. We've got a lifetime to write a game. Yeah. I will just end by saying I still think things are going quite well. The program still feels easy to reason about in little chunks. So yeah. Hopefully that was interesting and you enjoyed it. I will catch you on the next one.